Okay, so it's taking all 20 of those exposures. Basically, I think what I was showing in the earlier picture, right here, that's like one of the lower corners of that image. Anyway, Deep Sky Stacker is free, by the way. It went unsupported for a little while, but from what I understand, it almost seems like it may have gone the way of PhD. Now we have PhD, Open PhD 2. Somebody, I guess a group of people, they went ahead and took a hold of Deep Sky Stacker and started building upon this. This isn't the newest build. I think this is 3.3.2. I think the newest one is 4 something. So it's an older build, but it works.
Chris, is that open source software now? Where anyone
As far as I know, it is. I think yes. See that? I can't remember the guy's name who worked on this. I think it was a French guy. Does anybody know who put together Deep Sky Stacker? Okay. Anyway, but I think it is. Yeah, because I think more than one person is working on it now. So I'm assuming it is. But okay, so there's our nebula. It's nice and stretched. Now let's go and do what I did earlier with the single. This time I'm going to move my black. Just going to go over it until I can't handle it anymore. Do it like that. Bring this guy over. Bring our luminance curve over. Maybe about there. Okay. And we apply. So I'll bring that over a little bit. That's a little too much. Oh well. Anyway, you guys get the point. So if you remember, stretching that image, that's what I get. Whereas stretching the stacked image, I was not going to go back to it. You saw what I got. Anyway. Here's a 20 sub stack. That's what it is. There you go. Darn it. It's 32-bit, so that's why it's like that. Darn it. I think this one has it. Yeah, but it's not stretched. Oh well. Anyway, you get the point. So, let's see. Oh, I take that into Photoshop.
upgraded?
Yeah, I got it free from work. Isn't that great?
I'm jealous.
Don't work for me then. You laugh. That's it. That's good. Yeah, no more work with me. Anyway, okay. So there we go. That's what it looks like. But I don't know. Basically, what you were seeing, I think it was like this. What you were seeing in the PowerPoint was that section right there. My stars are a little egg-shaped. Actually, I think that's the optics right there. That's not the tracking or anything else. None of the other equipment. That's the optics. This was taken with a 200 millimeter Canon lens. That we put an adapter on the back, and I put the monochrome camera that I have. It's made by ATIC. It's the ATIC Model 428EX. It's only 2.8 megapixels, but it's kind of like Mike said. Like I said, when I was getting into narrowband imaging, I knew it was going to be black and white. I saw what kind of work was involved. And I was like, okay, well, I can see myself doing this for a while. So I went ahead and invested in a camera that wasn't super expensive. I think this camera is $1,300. How much was the 460? $2,500. Yeah, so $1,000 more I could have gotten twice the amount of resolution, but oh well. So I'll make do with this. I'm working on a mosaic with the North American Nebula and the Pelican Nebula. So, but anyway. Okay. So the next algorithm we're going to get to is sigma kappa clipping. What's kind of what's kind of cool about that is that it gets rid of what I like calling rogue pixels. Okay, so in the case of rogue pixels, the prime example we all run across here is like you got your exposures and you're ready to stack them, and then all of a sudden you see one exposure has a jet going across it, has a streaks of lights coming from a jet airplane flying over the object they were trying to image. Well, again, it wasn't there the whole time. So there you go. That's noise. So how do you get rid of that? Well, sigma clipping can get rid of that. So basically, if you know from statistics, I think I'm getting this right. Sigma is what represents the standard deviation. So if you have in your stack of images and it looks them over and it sees this one pixel that's just like way out there, it's just a really odd way out there outlier, then it gets rid of it. That's what kappa sigma clipping will do. So I'm going to do this pretty much on the fly because I did oxygen last night for not the Pelican, but North American Nebula. And there's not very much oxygen in there, but you will see a nebula. It's not going to be that great looking. Let's see. I think I only got 17 of that one for the moonlight just became a barrel. So let's fire up Deep Sky Stacker again. So my oxygen 3 set did have a jet in it, and I'll show it to you. So I hadn't even registered these pictures yet, so I'm going to go ahead and apply the dark files too. So I'll show you what a dark looks like, and sort of show you what the role it plays in as far as getting rid of noise, because we're talking about stacking here, which we want to get rid of noise also, as well as. I got that right. Yes, I will. Okay, anyway, we'll check all these. Yeah, hello. Here we go. Okay, I think it was, okay, so first off, let's look at just one of them. Okay, let me go back and stretch this right here. Okay, so you can see a little bit of the nebula there. It's not very bright at all, but there's not much in the way of nebula with oxygen 3, at least in this section, but you can see that there's nebula there. Now, that's this exposure right here. This is a 10-minute exposure, just like the Pelican Nebula. Now, let's look at this 10-minute exposure. I believe this is the one. Yeah, you see the trails? You can barely see it, but yeah, there it is right there. The jet flew across that. Let's see. I think you can see it fits viewer a little bit better. Let's see. Okay. Yeah, see it right there? Yeah. So, yeah, that was the only exposure that was in. So it was like, darn it, how do I get rid of that? Well, Deep Sky Stacker has that algorithm, and that will get rid of it. And it'll look at all my other ones. Well, actually, it's right there too. This may have been something slower moving. I wonder if it's geosynchronous around. Does anybody know if there's geosynchronous around North American video? That sickness? Okay, well, anyways. I guess we'll see what happens. Probably be very disappointed. Okay. Alright, so we'll go ahead and stack the check pictures. We're going to do, let's see, stack parameters. I'm going to do kappa sigma clipping. Hopefully this will get rid of the trails. So first what it's going to do is it's going to apply, actually first let me go back up here. Going back to the dark frame, what dark frame subtraction does. Okay, so you see what this looks like. Okay, now this is what a dark frame looks like. The dark frame is basically the same exposure but taken with the lens cap on. Is the best way to say it. Okay, so we want to look at what kind of noise is there that the camera is giving off, and nothing else, so whether it be from a jet airplane or a light pollution, or we want to see what the camera is getting on. There can be fixed pattern noise, there can be thermal noise, there can be the camera's read noise that could be interfering. So what you do is you take a dark, and that way you'll have a reference exactly of what the camera is doing to your light exposures, and then what will happen is that deep sky stacker will subtract the noise seen in the darks from your lights to make it a clean, get your sub-exposures to look clean. Anyways, okay, so let's see, make sure our signal is still there. Yes, it is. Okay, so we're going to go ahead and start, and we're going to create a master dark from it by averaging the darks together, just like we did the lights that we did in the previous example for the Pelican Nebula. So here it's putting them all together. It's going to make a master dark. Now I get to eat some food. I haven't even stacked these yet. I hope this works.
How many darks did you take?
Let's see, 17. Wow, I got the same amount. 17 lights, 17 darks. So you see it down there, right below? Right here?
Not from here.
Do what?
Not from here.
Oh, you guys, So there's light frames, there's dark frames, there's flat frames, and there's dark flat frames. Like you're going back on a combination of flats and darks. You take it at the exposure of your flats, the exposure of your dark, but like your dark, put the cap on.
So Chris.
Yes, sir.
You don't have to record darks all the time because we have libraries of darks. If we know the temperature and we collect the darks and exposure.
Yeah, that's correct, actually. There have been times where I look at the conditions of the night and the conditions of my camera, and remember how we have cameras that are able to actively cool our the sensor as the night wears on. The temperature is going to go up, but if we have a cooler over it, we can keep it at a constant temperature. Now, remember, we were talking about thermal noise. Well, the thermal noise is going to be exactly the same at a given temperature. Just keep the sensor at that temperature, and when you go to take darks for that, you can use those darks all over again for another night where the weather may be completely different. But as long as your sensor is the exact same temperature, those darks, you may be able to actually use those darks all over again. You don't have to sit there and take another set of darks. Of course, what I do when I take my darks, basically I just tear down my equipment, I get put the lens cap on, I get the darks rolling, and then I go inside with my camera and my laptop and batteries and whatnot all attached together, and I just set it down in my I guess foyer area, and I just say, here, just sit there, I'm going to bed. You know? So I just let it go all night long.
Chris, if you're taking darks, say you're taking luminance for over 3 or 4 hours, the temperature changes 15 degrees. Do you go for half an hour, take some darks, go for another half an hour, take some darks? How do you do yours?
No, if the temperature is the same on my sensor, I don't. So again, as long as my sensor is actively cooled, okay, say like the night goes from, I don't know, let's say 78 Fahrenheit all the way down, he said 15 degrees, well, let's just choose 65. Okay, so 65 Fahrenheit. So that's a huge swing in temperature. So at the end of the night, my noise is going to be different because it's cooler, because it's 65 degrees versus 78 degrees when I first started, okay? So the noise is going to vary from hour to hour. So what he's saying right there, would it be advisable to take a dark every now and then as the temperature goes down? And yeah, and he's correct. Yeah, you want to do that because you're going to have thermal noise at the higher temperatures than you would at the lower temperatures. Now, the way around that is like we're always saying, is that you can have a camera that's actively cooled. That'll keep your sensor at a given temperature. Most of the cooled cameras keep the camera sensor actually below freezing. So if you want to drive that thermal noise out of the closed picture. So But what he's talking about in the case of taking in darks over the period of night where temperature swings a lot, we mentioned earlier, if you want to get started, DSLR camera is a good way to get started. Well, DSLR cameras don't have cooled sensors. There's no cooler on the back of a DSLR. Okay, so its temperature is going to change throughout the night. Okay, so yeah, you probably would do what he suggests. Maybe you would want to take a dark, like maybe once every half hour or so. Yes, sir.
You could also have a space of time between exposures to let it cool down.
Yeah, you can do that too.
Put a fan just gentle on the DSLR.
Yeah, believe it or not, just all these little countermeasures, they do work. Okay, yeah. So I mean, you can just let it cool down if you want. Just give it a break or whatever. Maybe you can just go ahead and start taking your biases right then, or whatever. But yeah, I mean, you try to make the most out of your time, but also know the limitations of your equipment and make sure you have contingencies in place for
Hey, Chris,
whatnot.
just one thing. If some of you folks become interested in imaging, you want to try to do it with a standard Canon or Nikon DSLR. Darts are very important, but you don't want to waste time collecting darts when you could be collecting lights. So what you can do, if there's any DIYers in here, what I did is I got one of these thermoelectric igloo cores, and I modified it to bring cables in and out. And I was actually able to control the temperature. I put my whole camera inside, the whole DSLR inside of the igloo core. And I had a little thermocouple you can buy off of Amazon for $10. And I tried to get as close as possible to the temperature. You have to record the temperature when you're collecting the lights, but that could be hours of time that you could have been looking at another nebulae or something, If you,
So anyway, okay. Anyway, that's darks. So we'll go back to talking about stacking again. So Sigma clip in the middle. Let's see if it works. I got rid of those trails. I'm gonna go ahead and stretch it. Oops, too far. The way I did the previous one. Not much Sigma here. Definitely a lot of damn stars. So. So, yeah, that kind of distracts from the view. Oh, that came out better than I thought it would for oxygen. I thought the moon was really messing up my images there. But yeah, you don't see the trails anywhere. That's because that algorithm got rid of it. I'm curious if I were to go back. Now that it's registered, well, I don't know. Let's try this out. Let's go back and not do that. And use just is it averaging? Let's just use raw averaging. How about that? Let's do that. Okay, so we're going to do the same thing all over again. It shouldn't take us long because we already registered darts. Let's see what happens. Trying to go through the physics of it. Do you know if dithering could get rid of those jet trails? Like you're going throughout the night and you're getting rid of your fixed pattern noise, would that also a side effect? Would it get rid of the, no, it would not. I'm trying to visualize it in my head, moving the pixels around.
No, the key is to have enough frames that can estimate the population for the value of that pixel and identify outliers. So typically you need 8 to 9 frames before any of these rejection algorithms are effective. So you had 17, so it had a good sample of what that pixel probably is. So when that guy came through, it was like off to the side. I think that auto-weighted whatever also does some iterative clipping of outliers also. So, but average definitely just blindly throws them in.
Once you have enough frames, what you do is,
Depends, I mean, if your background level is 1,000 and you get a hot pixel at 40,000, then that may skew your
You also
average.
put in a
significantly.
rejection on the number, percentage of frames you reject. I think there's a,
Yeah, you can do that.
Yeah.
Also, there's a lot of stars in this area of Cygnus because I mean the Milky Way, what I like to call the Milky Way River, goes right through it, so it's very congested with stars. Deep Sky Stacker, when it registers your images, again, this is like applying the darks and stuff, has nothing to do with what this subject's about as far as stacking. It'll go through and look at those stars, identify where they are, and make sure that each frame, if your tracking is not super perfect, it'll say, okay, this star is over here, this star is over here. Okay, it goes to the next frame. Oh, this star is a little bit up there, and so is that one. So it stacks the images according to exactly where the stars are and aligns them on top of each other. Well, what will happen, some of the different settings that you can mess with in Deep Sky Stacker is star detection. If you were to do star detection on this area of the sky, Deep Sky Stacker would keep you up all night long because it's counting every one of those stars. So, I mean, but you look at it from here, we don't have it, we haven't really brightened it up enough or stretched it enough so that you can see the nebula or anything like that, so you don't see all the stars here. So we have a quote handful here, what, a few hundred here, okay, per se, okay. I don't even know, did anybody keep track to see how many stars this one I think was counting originally when we first did it? Anyway, I'm sure I picked up a few hundred, but if you were to tell Deep Sky Stacker, say that any star that's this bright down to very, very, very dim, I want you to count it, it'll probably count like more than 1,000. So, excuse me. So that'll keep you up all night. But again, that's just Deep Sky Stacker. Has
in this
nothing to do with stacking.
area, if you even put it down to only 10%, you still come up with 15,000, 20,000, something ridiculous. And then it takes like a half hour.
Well, in that case, I don't feel sorry for you. That's because you have more. That's because you have more megapixels than I do. So. No, I don't see the trails. Oh, no. Is it? No. Right, let me go back and look at it and it's right here. Okay, so yeah, I was going through Yucatan Peninsula there. Yeah, I don't really see it there. It wasn't very bright, so maybe that's why I'm not seeing it. Does anybody else see anything? Okay, well, anyway. There you go, North American Nebula. It is, again, it is mirrored. It's supposed to look something like this, flipped. Anyway, let's save this. Okay. Anyway, so there's that. Now, so going back to the actual presentation, so we saw what Sigma, well, I tried to demonstrate what kappa sigma clipping does. I mean, we saw that it got rid of it from the individual exposure where the jet satellites or whatever that stuff was that was in there, and well, kappa sigma clipping got rid of it. So anyway. The other one, unfortunately, I don't have the subs for this, so I can't demonstrate it. Plus, two, it'll probably take a little while because this is from a 16 DSLR camera. This is a DSLR, by the way, when we're talking about earlier. So, entropy weighted average. Basically, entropy meaning, or in this case, intensity is the best way I'd like to call it of each pixel versus another exposure of the same object. What this allows you to do is what we were talking about earlier. Who was it? I think it was him that was talking about combining stacks of different exposures. What this will do is it will do everything simultaneously. You can put your 30-second second exposures in with your 120-second exposures, and you'll get a nice evenly lit object here. And I wish I could demonstrate this. I haven't. I got it somewhere buried in my book bag there. Some exposures of what the Orion Nebula, which is what this is, would look like if you expose it for a long time so that you can get all this nice nebula velocity out here. I could have exposed it a lot longer and got more of this area filled up with nebulosity. However, what's the brightest section of this picture? This guy right here.
Yeah.
Called a trapezium, okay? You look at it through a telescope, trapezium is the first thing you're going to see when you look at the Orion Nebula. So that means if I want to expose, set my exposure really high to get this area to show nebulosity, this thing is just going to be drowned out, super bright, okay? So what I do is I take, I set up shorter exposures where I get a nice resolved area right in here where it's not, where all the pixels have not been filled to capacity and it's not just white anymore, or saturated rather. So that's one way around that, and that's what this routine does. Sorry, I don't have the data set on me to demonstrate it. Yes, sir.
What are the requirements on the exposure that you take for this algorithm to work?
So I've only gotten this, of the only ones I've, how can I say this, the only exposure sets I've ever done with this was, hopefully this will answer your question, I've done 30 second, about 120 second, and I did 5 minutes, a combination of those.
So you did bracketing?
Yeah, bracketing, okay. So that's another fancy term that you would use. Bracketing, it's been around for years. It's a term that's used in photography in general, okay. So, I mean, that's basically, he mentions that. So I had a lot of bracketed exposures of that eclipse that came over 2 years ago. So that's a shorter exposure, and that shorter exposure, what's nice about it is I was able to see the prominences on the edges here. Now my longer exposures, you see all these rays coming from the corona right there, okay? The longer exposures, I was able to get those rays to show up more, okay? When I got the rays to show up more, the rays would go out to about here and they would fade away, and then if I did another longer exposure, I could get the rays to be exposed all the way out to here, and so on and so forth. So, but when I got the rays to expose out here, the same thing was going on here in the middle. It was very, very bright. Okay, it was very distracting. Got to see the details out here, but we lost all the details here because the pixels were saturated. They were just white, is what they were. So, but
Wait a minute.
this is basically what you get when
you
to what?
Never mind. I was going to say you were going to tease us with that description and not show it to us.
Okay. So yeah, there you go.
Yeah.
So this is So this was from August 21st, 2017. And actually, I got the T-shirt here. So, but anyway. So let's see what else. I think that's pretty much the end of my presentation. Yeah, that's it. All right. Any other questions that I might be able to answer? If not, I'm sure someone else in here may be able to.
Question about, let's say, shooting the Milky Way and you've got foreground objects.
Okay.
Can
Yeah.
you stack those?
Can you stack for?
So if you've got,
I actually looked that up a long time ago because what I wanted to do in one situation is I wanted to stack Star Treks. And I wanted to put it in a time-lapse movie so I could watch the world just tilt on itself, okay? And I found a website that shows you how to do that, but then in my search I did find that. I did find where you could find where you could use Photoshop to stack your Milky Way image, and any like trees that are silhouetted in the foreground or whatever, you can make those sit still. There is a way to do it. It can be done. Yeah, it can be done. That's my best answer.
Yeah, you basically have to take foreground objects out, and stack the background, put the foreground back in.
Yeah, yeah,
layer
sort of.
back in.
Right.
Chris, let me ask a question. But like with, what about like, with auto stacking? Like you get, on some of the programs, like when you're actually, you have your camera, and.
You said auto stacker?
Yeah, auto stacker. Like you basically, no, that's auto stacker. I'm talking about like,
Live stack.
like in SharpCap, where you can basically, you can live
Oh,
stack.
you can live stack?
Yeah.
Yeah. I've only played with that briefly.
What
Do
was
I
the
still
question
have, I
again?
have SharpCap right here, but I don't use SharpCap that much. The only reason why I downloaded it was to actually see that.
Oh, yeah.
And
Yeah.
I think all it did was average each exposure.
It's the same concept though.
I mean, it's the same thing, yeah.
Yeah.
I mean, if that's what you're asking, but I don't know.
He's added some rudimentary pixel rejection, but to do what, you know, PixInsight's doing with pixel rejection in real time would not be fast enough, but he's cheating, but I think he gets most of the hot pixels, which is what you're worried about getting rid of.
Yeah.
So, but I haven't tried that.